You're live. Okay. Number 1. Okay, so first of all, 3/2020. So our objective is basically we're going to be we're reviewing functions. So tomorrow's test, I'm going to ask a couple of questions. I'm going to ask things like, is this a function? Is it linear? And you just have to circle the correct answer. So on the test, you just have to circle the correct answer. Does that make sense? So we're going to do this. Okay, so graph number 1. So for y equals 5, I'm going to go up to 1, 2, 3, 4, 5 on the y-axis. I'm going to draw in a linear graph at 5. So the reason it's the horizontal is because the y values are always 5 on this, so y will always equal 5. Is this a function? Yeah, it's a function. Yes, that is definitely a function because it only has one y value for each x value. It passes, remember it passes the vertical line test. So yes, that's a function. Is it linear? Is it straight? Yes. Good. Can you do that tomorrow? No. Thumbs up?
Maybe.
Okay.
Yeah.
Okay, number 2. So, first of all, is this a function?
No.
I don't know. So, maybe if we could graph it first, we'd get a better idea. So, if I have to graph this one, what do you think? Maybe we could do what Rye showed you in our warm-up. So what did Rye show you? Cover up, right? So we did the cover-up method. I would get a y value. My y-intercept would be at 0, negative 4. Do you agree with that? If I negative 5y equals 20, divide by negative 5, I get negative 4. So I'd have a point at 0, negative 4. 1, 2, 3, 4. And if I did the cover-up method here, I'd get an x-intercept of 5, 0. So I can put a point at 1, 2, 3, 4, 5, 0. Now, here's how you can know it is linear. Okay, always remember this. My exponents are 1, aren't they? They're invisible, but my exponents are 1. That will always be linear. If you get an x squared, it's not straight. X cubed is curvy. Anything but plain old x will always curve. But if it's plain old x, like just plain old x, not x squared, it will be a straight line. It is linear. Here's my graph. Is this a function? Yeah, that's a function. It passes the vertical line test. Yes. That's a function. Is it linear? Is it straight?
Yes.
Yes. Okay. Why are they? Oh, great question. For this number 3.
Why is there 2?
See, there you go. Might not be a function. Might not be a function. Let's take a look at it. So number 3, let's grab it. So this is a point at negative 2, 5. So I'm going to go negative 2. Oops, it's off my graph. That's okay. Negative 2, 5. I'm going to go 1, 2, 3, 4, 5. Negative 2, 5 is here. Negative 1, 6 is there. 0, 7 is here. Negative 1, 8. Uh-oh. Gonna have a problem there, aren't I? Right? And then 2, 2 is here. Now, Giselle saw it right off the bat. She goes, wait a minute, Mr. Davies. Why are there 2 negative 1s, right? That's a problem, isn't it? So, first of all, let's answer this one. Is it a function? No, this is not a function. And you can do, if you want to, you can do the vertical line test, right? And right here, boom. If you have a vertical line that hits any point twice, that means this x value has 2 corresponding y values. Can happen. It's like having a latte with 2 different prices, right? Won't work, okay? So it is definitely not, oops, I want this one. It is definitely not a function, okay? Now, we can still say it's a relation. So we can still state the domain. So the domain's got to be these numbers. The numbers are my x value is negative 2, negative 1, 0, and I've already said negative 1 and then 2, okay? If you put -1 twice, I would still accept it, okay? And then the range is the corresponding y value, so this is my domain. And my range is going to be my corresponding y value. So my range is going to be these values, which is going to be my 5, 6, 7, 8, and 2, okay? So domain's just my y values. Domain's just my x values. Strike that. And range is my y values, okay? Thumbs up? Okay, good. Now, is it discrete or continuous? Now, that was something we talked about. It's discrete because to be continuous, it's got to be nice flowy lines. That makes sense? It continues nice and flowy. Discrete means it's like point, 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 point. Discrete means it's a countable number of numbers. So this one is definitely discrete, okay? They call it discrete because you can actually count the numbers. That makes sense? It's a flowy line. You can never count all the numbers, could you? No, it goes forever, right? All right, now, number 4. If fx equals 2x minus 3, well, again, this is what y did for us. Let's plug in -2, let's plug in 0, and plug in 3. So I'll say f of -2 is equal to 2 times -2 minus 3. There are 3 questions in here, so I'm just going to do the first one. I plugged in -2. So f of -2 is equal to -4 minus 3. I just multiplied 2 times -2. Or f of -2 is -7. I saw, and that's totally the answer. I saw somebody do this earlier, and I thought that was really cool. I think, Edie, was that you who did this? I think one of you guys did this. You made it into a point. Somebody out here did this. You don't have to, but that's really awesome because it is a point. But this is all I need, okay? That's all I need. F of 0, okay? F of 0 is equal to 2 times 0 minus 3. 2 times 0 is 0. So f of 0 is 0 minus 3, or f of 0 is -3, okay? How am I doing? And then finally, f of 3 would be f of 3 is equal to 2 times 3 minus 3. F of 3 is equal to 6 minus 3, or f of 3 is 3. Okay, turn the page. Okay, number 5's different. It doesn't say plug in a number, does it? It says make fx equal to 2. It's different. So I'm not going to plug in 2, but I'm going to say f of x. So write in fx is equal to 2. So instead of writing fx, I write 2 is equal to 4x minus 10. So instead of writing f of x, I put 2 right there. And now I'm just going to solve. Plus 10, plus 10, 12 is equal to 4x. Divide by 4, divide by 4. X is 3. How's that? All right, number 6. Find the x and y intercepts. All right, let's do the cover-up method. So if I cover up my y, I've got 3x equals 12 or x equals -4. You guys agree with that? Do I need to show that? You guys see the -4 if I cover it up? Right? So I'd have 3x equals -12 or x equals -4. So that would be a point -4, 0. And then the y-intercept, I'll cover up the x, and I'll have a -4y equals -12. Divide by -4, divide by -4. I have y equals 3 or 0, 3. Okay, now after I've graphed, that's going to be pretty easy to graph, right? So I'm going to go to -4, 0, which is 1, 2, 3, 4. There's my x-intercept. And 0 and -3, 1, 2, 3 is there. I'll connect the dots. There's my line. How am I doing? Okay. Okay, number 5. We're almost done. Find the slope from this table. Well, slope is always going to be the change in my y's, because rise, overrun, over my change in my x's. That's what slope is. It's rise over run, so it's the change in the y values over the change in the x values. So, well, looks to me like my x's are going up by 2, up by 2, up by 2. My y's are going up by 5, up by 5, up by 5. So my slope is y's on top. It's going to be y's on top, then x is on the bottom, or 5 over 2. There's my answer. Good. You can do that tomorrow too, can't you? Okay. Okay, 8. Last but not least, we're almost there. So tickets are sold at a dance. The cost of the gym to rent is $100. The income equation, I of n equals 35n minus 100. Represents the dance income. Okay, so $35 per ticket. The negative 100 because we had to rent the gym. So we had to dole out some money, right? We're behind $100, okay? What is the independent and dependent variable, okay? So the independent variable is always going to be the main variable, okay? Or better yet, what are we trying to do here? Number of tickets. Independent. As we sell tickets, we make money. So my independent variable, independent, is n, is my independent variable. Or if you want to say it's just the number of tickets. So let me give you another way to put this, okay? I independently get to decide how many tickets I get to buy. Does that make sense? I get to decide how many girlfriends I want to take to the dance, okay? So I can independently, I only got one. Only one I'm going to take. Anyway,
Take 2.
I can,
Player.
yeah, my daughter. There you go. And my wife. So that's my independent variable, right? I can decide. Now the price is dependent on how many tickets I buy, right? Does that make sense? So then the dependent variable is the price or the income. Dependent is the income. So I can choose independently how many tickets to buy. That's my independent variable. But the income is dependent on how many tickets I buy. Okay. Now finally, if 150 tickets were sold, what would be the income? Well, that's easy. Just plug it in, right? So I'm going to go, okay, I'm going to go I of 150 is equal to 35 times 100 minus 100. So I'm just plugging it in. Plugging my 150 into my equation. So I of 150 is equal to 3,500 minus 100, or I'm going to make $3,400, okay? This is off the record, but honestly, you guys, when you're seniors and you're trying to make money for your big senior class trip, this is how they make all their money is prom, when they're juniors. They make all their money on senior prom. They'll make $5,000 on one dance. It's crazy. Did I make a mistake?
The tickets cost 35, 150.
150. I did make a mistake. That's what you said. Okay, I'm on the record as making a mistake. Here we go. 150. Hold on. Thanks, Giselle.
You're welcome.
Times 150 minus 100. How about 5150? Good thing there's retakes, right? Okay. Now, second part says if the class made $7,705, so I'm going to say that's my income, right? How many tickets did I sell? I'm just going to solve, provided I don't make a mistake, right? So just made my income equal 7,705. I'm going to go plus 100 plus 100. I'm going to go, that's going to be a 7,805 equals 35n. Divide by 35, divide by 35, let's see, 7805 divided by 35, and I get an answer of 223 tickets, right? Okay, let me go ahead and stop the recording.